Okay, so let's go ahead and talk about section 2.1. 2.1 deals with functions. Functions are very important for the topics that we'll be discussing in this course. One way to think about a function is that simply you're putting something in and you're getting something back out. You might think about it if you're putting a problem into your calculator. You put in the question, you get exactly one answer back, then that's an example of a function. If you're getting multiple answers back, then that's not a function. If you're not getting anything back out, that's not a function. So with a function, you're putting something in and you're getting exactly one output or one thing back for your answer. Let's start by talking about what a relation means, and then we will build on that. A relation is simply a set of ordered pairs. So here's an example of a relation. You'll notice I've got the curly braces on the ends. That's my set notation. And then I've got three ordered pairs inside. If you recall, ordered pairs simply have an x coordinate. For the first coordinate is your x value. The second coordinate is your y value. And of course, these can be graphed. But with a relation, the relation is just a set of ordered pairs. A function is a special type of relation. If you have a relation where each x is being matched with exactly one y value, then you have a function. So for example, well, let me ask you with this example, would you say that this relation is a function? Does each x get matched with exactly one y value? Yes, it does. All right, so you've got x equal 2 gets matched with 3. When x is 1, it gets matched with 5. When x is 4, it gets matched with 6. So you could also think of this as saying, if you put 2 in, you get a 3 back out. If you put 1 in, you get exactly one value back out. If you put in the 4, you get exactly one value back out. All right, let's look at another example. So we're going to try to determine if a relation is a function. So what about, so this one we said yes. All right, is the relation a function? Okay, so what if we've got the set with ordered pairs 1, 5, 2, 3, and 4, 5. And let's do one more. Maybe I've got ordered pair 0, 7. Okay, so this time I've got a set of 4 ordered pairs. I'm trying to determine if each x is being matched with exactly one y value. So you'll see I've got x equal 1 gets matched with a 5. When x is 2, it's being matched with 3. When x is 4, it's being matched with 5. When x is 0, it's being matched with 7. Does each x value have exactly one y value associated with it? The answer is yes. You may be noticing that you've got a repeated y value here of a 5. So you have two x values that are being matched with the same y value. But that's not violating the definition of a function that you have in your notes. So if you read the definition of a function, it states that each x value is matched with exactly one y value. So again, unless you've got an x value that's not being matched with anything, or unless you've got an x value that's getting matched with more than one y value, you've got a function. Okay, so when x is 1, y is 5, and when x is 4, y is 5, but it's still exactly one y value associated with each x. So this one is yes, this one is a function. Okay, let's look at another one. What if we have ordered pair 2, 6, ordered pair -3, 5, ordered pair 2, 8, and ordered pair -1, 6. So again, if this is a function, each x value should be matched with exactly one y value. Think about that. Pause it for a second if you need to. Okay, so this time you're probably noticing the repeated 2. These are x values. Over here you have when x equals 2, it's being matched with y equals 6. Over here we have when x equals 2, it's being matched with 8. Okay, this time we've got the same x value 2, being matched with two different y values, and that violates the definition of a function. When x equals 2, it's going to two different things, two different y's, so this one is not a function, so this is no. Okay. So what if we have a relation that is given to us in the form of a graph, and we're asked to determine if we have a function? This is pretty easy to determine from a graph. You're just going to look at the vertical line test in your notes. Take a look. You'll see that the vertical line test states that a graph is the graph of a function if and only if no vertical line can touch the graph in more than one place. So looking at A, so just make sure you can distinguish between what exactly do I mean by the graph. The graph is the picture that's drawn inside the Cartesian coordinate plane. So we've got the x-axis and the y-axis. We're not really worried about how many times our line touches those. We're interested in the picture. So how many times can my vertical line touch this picture here that I've drawn? Well, if we look at it, over here it's not touching it at all, and that's fine. As we move in, we've got a vertical line touching the graph in two places, here and here. And of course, it doesn't really matter where I place the vertical line inside this shape. It's still touching it in more than one place. And because it's touching it in more than one place, this graph is not, this one we would say it fails the vertical line test. The graph is not a function. Okay, so you can say no, because it fails the vertical line test. All right, let's look at graph B. All right, over here, we've got a graph that the arrows on the ends are indicating that it's gradually spreading out in each direction. So as we move in from the left side, is there any way that my vertical line could ever touch, is there any way I can place this vertical line in here to make it touch my graph in more than one place at the time? No matter where I place it, it will always only touch this graph in one place. So this one passes the vertical line test. This graph is a function, so we'll say yes, it's a function. And in part C, we've got a piece in the top and a piece in the bottom. Again, we're interested in how many times a vertical line, any random vertical line, might touch the graph. Well, if I put it here, it's touching the graph here, and it's touching the graph here. That's more than one place, so this one fails the vertical line test. It is not a function. So vertical line test should be pretty easy for you to use. Please let me know if you're not grasping it. Sometimes people just don't quite see it for some reason, but then once you do see it, it's really easy. So just please let me know if you're not seeing it. I'll be happy to help you with it some more. All right, example 3, we are asked to determine whether the equation defines y as a function of x. So again, what you're asking yourself here is, does every x value get matched with exactly one y value? If you look at part A, just choose an x value that you want to play with. If you let x equal 1, then you would have the absolute value of y equals 1. What value of y would make this true? And can you think of more than one that might make this true? If y equals 1, you've got a true statement because the absolute value of 1 equals 1. Is there anything else that you could put in for y that would also give you a true statement? Yes. If y equals -1, you're going to have the absolute value of -1 equals 1, and that's also a true statement. So what does that tell us? We found that when x equals 1, we've got two y values that are going to work for this. So you've got an x value that's being matched with two y values. Would that be a function? No, it's not. That's not a function. So this one is no. If you want to think of this in terms of ordered pairs, we found that for the example, for the numbers that we chose, we got x equal 1, y equal 1, and then we got x equal 1, y equal negative 1. And so you can see that you've got an x being matched with more than one y value. Look at part B. In part B, you'll notice that the y is sitting over here all by itself, and it's defined, this basically over here is defining our y value. So in this one, you're putting numbers in for x, you're doing some operations to it, and then you're getting an answer back for y. Is there any way that you could put a value in here for x that would give you more than one y value? This time, because you're putting numbers directly in for x and your answer is giving you your y, this one's a little bit easier, in my opinion, to determine, because you can put in anything that you want for x. You're going to square it, and then you're going to subtract 3 times that original x and then add 2. Could you think of any way possible that you could get more than one answer back if you did this? This is one of those where you could just type it straight into the calculator. Would the calculator give you more than one answer? No, it won't. There's only going to be one answer associated with any x that you put into this one. So this one is a function. This is yes. As you do more of these, you'll notice that any time that you've got y solved by itself on one side of the equation, you've got y defined to be this function over here, or this relation if you want to call it that. And if you've got y already solved by itself, it's going to give you a function because you're going to put values in for x and get one answer back for y. What about part C? Part C, we've got x squared plus y squared equals 1. All right, so we'll just put a number in this time and kind of play around with it. Let's keep it as simple as possible and let x equal 0. If I put in 0 for x, I would have 0 squared plus y squared equals 1. So I want to solve the equation y squared equals 1. But we know from working with quadratic equations that this would be a really good time to use the square root property. I can take the square root of both sides of this equation, and I would get y equals, all right, and remember from the square root property, we're supposed to do plus or minus the square root of our constant. So plus or minus the square root of 1. So we're getting y equals plus or minus 1. What does that tell us? When we put in 0 for x, how many y values did we get back? We got 2 possible y values. So we've got 2 ordered pairs. We've got the ordered pair 0, 1 and the ordered pair 0, negative 1. Is that a function? No, that's not a function because you've got one x being matched with more than one y value, so not a function. Let's talk about domain and range. We can talk about, or we can discuss domain and range in terms of either a relation or a function. The domain is simply the set of all x coordinates. The range is the set of all y values. In example 4, we've got 3 little problems that we want to look at. In part A, we've got a list of ordered pairs or a relation. What is the domain of this relation? It's simply the x values. So we're just going to list the x values of negative 1, positive 3, and then here you've got positive 3 again, but there's no need to list the same one twice. So we just got negative 1 and 3. Our range would be our set of y values. So you can probably write those down pretty easily. Go ahead and do that. You should have 1, 9, and negative 9 for your range. Is this relation a function? No, because you've got, when x is 3, it gets matched with 9, and then over here you've got the same number being matched with negative 9. So you've got an x value being matched with more than one y value. This is not a function. Okay. Part B, we've got an equation this time, y equals the square root of 2x minus 1. So the domain, again, is the set of all x values. What values can I put into this for x? With this being a square root, I do have to keep in mind that we are working with strictly the real numbers here. We're not getting into the complex or the imaginary numbers. So working with the real numbers, I have to put numbers in here for x that are going to keep the inside of my radical positive. Meaning whatever is inside here, this 2x minus 1 piece has to be positive at all times. So let's go ahead and look at just that. If 2x minus 1 is positive, that means it has to be greater than or equal to 0. Solving this for x is going to give me the domain. If I add 1, well, I'll let you do that. You can solve that for x. Take a second. Pause it if you need to. Add 1 to both sides. 2x is greater than or equal to 1. Divide both sides by 2, so x is greater than or equal to 1/2. And we can give this an interval notation. If x is greater than or equal to 1/2, then we're going to say that we have the domain from 1/2 with a square bracket, comma, positive infinity with parentheses. Range, of course, is the set of all outputs or the set of all y values that we can get for this. What possible answers could we get? Y is defined to be the square root of something. And we know, what do we know about square root? Square root will always be positive or 0. It is impossible for y to equal a negative number here because the square root quantity will be positive. So our range is going to be y has to be greater than or equal to 0, which we can write in a square bracket 0, comma, infinity. And as I don't remember if my math lab is going to have you write this as an inequality or an interval notation. I suspect it's interval notation, but I'm going to go ahead and give you the inequality as well so that you can see both. For the domain, if I were to write the domain using an inequality, I would say because domain is x values, I would say x is greater than or equal to 1/2. For range, because range is y values, I would say y is greater than or equal to 0. So these answers are acceptable unless you are specifically asked to give your answer in interval notation. Okay? Is it a function? So again, to determine if this is a function, you have to decide if there is any way that you could have any x value being matched with more than one y value. Is that possible? Well, you'll notice here that you've got y already solved by itself on one side. So this means that y is defined by this side. Here you're just putting numbers in for x, doing some operations, taking the square root. All right, if you were to do this on the calculator, is it possible for you to get, what possibilities could happen here? If you put a number in that's not in the domain, like if you try to put in -7, what's going to happen? Probably going to tell you error. If you want to type that in on your calculator and do that, go ahead. It's going to give you something back that's not an answer. So, but that doesn't really count because that's a number that's not in the domain. What happens if I put numbers that are in the domain? So if I put anything from 1/2 to positive infinity, if I put that in my calculator for this problem, how many possible answers does it give me back? And just think about that for a second. Let's say if you put in 6 for x. If you put in a 6, 2 times 6 is 12, 12 minus 1 is 11, and you take the square root of 11, it's going to give you a decimal, but it's going to give you exactly one answer. It's never going to give you multiple answers. If you put in values that are in the domain, it will always give you exactly one answer back for your y. So do we have a function here? Yes, we do. Because every x that I put in that's inside my domain will always give me exactly one y value back for my answer. What about part C? What is the domain? The domain is a set of all x values. So we have x is equal to an absolute value. Similar to the last problem, just like with the square root. If you've got x equal an absolute value quantity, what does that tell you about your signs for x? X has to be positive, okay? So if x is positive, then the domain is going to be square bracket 0 to positive infinity, which is also the same thing as saying x greater than or equal to 0. What about the range? What possible values can go into this for y? Could I put in a -8 for y? Yes, I can, because y is inside the absolute value. I could put a -8 in here and then take the absolute value of -8 to get my x value. So y can be positives or negatives. So y can be anything. So we'll say it's the interval -infinity to positive infinity. Or we could also say it's all real numbers. Is this one a function? X equal absolute value y. If it's a function, that means that every value that you put in for x will always give you exactly one y value back. Will that happen?